Good morning, everyone. Thanks for joining the DevOps room. I think you've made the right choice. This is where the cool stuff happens. So I want to talk today about test-driven security in the DevOps pipeline. And this is going to be a very practical talk. I'm going to show how we did a lot of these things at Mozilla over the last couple of years. And I think it's important to really understand why these topics matter today. We've seen DevOps gain a lot of traction in the industry over the last few years. It's nothing new. Developers have been doing Agile since the late 90s. They pushed it over to Ops, saying, this is the right thing to do. You should adopt it. It became DevOps. And in the last 3 or 4 years, we've seen security teams try to adopt as much of these techniques as possible. And where I think the value really is when you look at a company like Instagram that essentially was a team of not even a dozen people, built a billion-dollar business, mostly by adopting DevOps principles, automating the heck out of everything, deploying multiple times a day, moving really, really fast, and building a product that had a lot of value, and they could sell to Facebook for a gigantic bag of money. And if you look into the technology world and the startup world, it doesn't matter if you're a small company or a big technology giant in healthcare, in banking, it doesn't matter where you are. Everybody understands nowadays that you need to move fast. You need to adopt these principles, these DevOps techniques, in order to build value for your organization. And as security teams, we tend to be behind on these things. And we've seen developers and ops move very fast and adopt new techniques, and we're still doing manual testing. We're still doing manual security reviews. We're still doing gating deployments once a quarter whenever we can approve of a new version of a software. And this is changing. We need to adapt. And this talk is about essentially explaining how we adapted Mozilla to these things. So my name is Julien Veillant. I manage the Firefox operations security team at Mozilla. We take care of the security of Firefox backend services. And some of them you may know. If you use Firefox and you have an account, you've used Firefox accounts. If you've installed an add-on or web extension, you've used addons.mozilla.org. But a lot of them you've never heard about. We have a service that will push data to Firefox to do tracking protection and protect you from being attacked on malicious websites. We have an entire backend API and set of APIs that will update Firefox preferences in the wild, or push blacklists of malicious add-ons or certificates. We have a data synchronization service that users can use to synchronize data across multiple Firefox services, installations. And all of these backend services are invisible to the end users, but they carry a lot of risk. If they're compromised, it's a large amount of the Firefox population that is at risk. So we need to make sure that we always keep them at a very high level of security. And that means being able to move with the development team, with the ops team, as fast as they move. When they add new features, we need to be moving at the same pace to guarantee that level of security. I wrote a lot about what we developed at Mozilla in the book Securing DevOps that Manning was kind enough to help me publish. This isn't out yet, but you can get the pre-version. And they were nice enough to give a discount code if you're interested in Manning books. You get 40% off. You can find me on Twitter, and that's about it for me. So before we dive into DevOps, I want to talk about something that makes me regularly very sad. And that's a bug bounty program. And I don't think anyone here needs to be explained what a bug bounty program is. We've been talking about them for years. Most organizations have one today. It's very easy to create one. And it's a great way to invite external researchers to essentially test your applications and make sure that you don't have any vulnerabilities. And if you do, you give them some money, everybody's happy, you fix the issue, and you move on. It's great. And we have a triage mechanism at Mozilla because we get a lot of bug bounty reports. And on Tuesdays, it's my turn to triage bug bounty reports. And the thing about bug bounties, there are a few things about it I want to talk about. The first one is it's kind of a training wheel for like junior security engineers. And every once in a while, we get a report like this one. I have found a source code disclosure on Mozilla.org. right-click view source, and he can steal all the source code of the server. This is a major vulnerability. You can have a bounty now. And if you talk to people who have done bug bounties, they've seen those because they come along every once in a while. And we try to be nice because obviously, this isn't someone who is well-versed in security, but maybe one day they will be. So we try to be nice to them. And we reply something like this. Dear security researchers, we appreciate your participation to Mozilla's bug bounty program. However, this is not a vulnerability, but simply a feature of the web, and thus not available for bounty reward. Pretty reasonable answer. Why don't you pay a bounty? It's a major vulnerability. I've hacked the NSA with it. You must pay me a bounty. Or a T-shirt. Can I have a T-shirt? And those happen. They're not the most annoying ones. They're kind of funny. But the ones that really make me sad are the good ones. And this is an example of a bug bounty report we received a while ago from a security researcher who found a reflected XSS on hg.mozilla.org. And hg.mozilla.org is kind of our own little version of GitHub. Like we put all of our source code in it. And developers use the web interface to browse the source code and link the source code to multiple, across devs to participate in the program. And this vulnerability is your typical reflected XSS query string parameter. We've seen those. And it's particularly dangerous because it's on a site that pretty much all core Firefox developers will use. So if someone were to use this vulnerability and attack core developers, they could essentially gain access to environments that could harm the integrity of Firefox. So we're particularly worried about those. But what makes me particularly sad here isn't the fact that we found an XSS. They happen. We know how to mitigate it. You can either escape that or you can put a content security policy on it. But the problem here is this is something we've known about for years. We know XSS. We know how to mitigate them. Content security policy is nothing new. Libraries to escape user-submitted content are available in every language. And yet, we're still finding bugs on this kind of vulnerabilities. And that's a problem I have, not with bug bounties, but with the fact that, one more time, yet again, we've shipped code that is insecure to production. And we do that quite a lot. These are statistics from our bug bounty program that I pulled out a couple of days ago. So they're for this year. And you can't really read what's on the left column here. But the long blue bar that goes all the way to the right is XSS type vulnerabilities. Now, on this particular one, there any type of XSS. I'm not looking at the potential impact, but you can see that it's a whole lot of them. And then you have injection attacks and authentication attack. You could pretty much take this and be like, this is Mozilla's internal OWASP top 10 kind of thing, because that's what we see in bug bounties. And all of these issues are things we know about. Right? There's nothing new here. There's no new discovery. There's no 0 day on a buffer overflow that someone managed to reverse engineer some of our code and exploit some magical vulnerability in a corner. No, this is all pretty basic stuff. And if we look at the impact and how we rank these things, sure, 43% are low. They don't really have an impact on our infrastructure. But 23.9% have been ranked as high. At that point, when we classify something as high, it means it can actually be used to harm users or employees, either or, if it's an internal site. And almost 4% are critical. And a critical vulnerability means essentially that you can attack a large amount of users by exploiting that vulnerability. So there is an impact here on the security of our organization, the security of Firefox. And it costs us money, too. This is the bug bounty payout for our web bug bounty program. And you can see here, we have a categorization by sites, because we have a lot of sites at Mozilla. Everybody makes websites at Mozilla, from core web dev team to accounting. Everybody makes a website. So we have hundreds, if not thousands, of websites. And so we only pay bounties on the ones that really have an impact to the organization. But you can see a remote code execution on a critical site is going to be paid $5,000, authentication bypass $3,000, et cetera, et cetera. At the end of the year, that's pretty close to what you would pay a full-time employee when you end up paying the bug bounty program. So the question here really is, Can we increase application security by finding these issues before they reach our production systems? Because it's really counterproductive to do it after the fact. Bug bounty programs are great. They are really indispensable to everything we do today. But they find issues in vulnerabilities that are already on production systems. They may already have been exploited by a malicious attacker. And that is the problem we're trying to solve. We don't want these issues to be found once we're on production system. We want them found before we get to the production systems. So I'd like to take a little bit of a detour here and talk about DevOps a bit. And I'm assuming everybody in this room is familiar with the basic idea of DevOps, but let's break it down. There are really three components to DevOps. The first one that comes from Agile is you want rapid release cycles. You don't want to release your software only like twice a year, and every time you release have 100 new functionalities, thousands of lines of code changes, et cetera, et cetera. That's too big. And it's too difficult to release, and the probability of breaking user backward compatibility is too great. So you want rapid release cycles. You want to take a subset of the features you're working on and release them regularly. That's the first thing. But in order to do that, particularly for web applications, you need to have automation, because you can't just manually release your software every day. That's too time consuming. So you need global automation of integration and delivery pipelines. That's what Instagram did great. They had the ability to push our code to production multiple times a day by just pressing a button. And that's why they were able to iterate so quickly. The third one that people often overlook is that in a DevOps organization, you don't want to be separated by departments. You want to build teams that collaborate together quickly and efficiently. So for example, if you're building a new product, one thing that you really want to do is to take a couple of developers here, maybe an ops or two here, someone from QA, someone from security, a product manager, and you bring in someone from marketing as well. And you create a project team. And these people are going to be working together for a few months on that one project. And there is no barrier to them talking to each other. When the devs are ready to deploy, they just talk to the ops right here. They don't have to go through the deployment processes of talking to another department that goes through 3 managers and take 4 weeks. That's not possible. This is way too slow. So this collaboration notion is very important. And this is where, as security teams, as consultants inside our organizations, we need to be very, very active. This is what a typical DevOps pipeline looks like. And you could replace any of these particular vendors or products with something else. It doesn't matter. But this is what we use at Mozilla. So you have a developer on the left who writes code and pushes that code to GitHub. And when the code is being pushed to GitHub, a webhook will call a CI environment. Travis CI, Circle CI, use GitLab if you want, use Jenkins if you want, doesn't matter. A CI environment will run every time there's a code change, a pull request, a tag release, something like that. And when that happens, then a number of unit tests, integration tests, et cetera, will run on the code, right? What we also do in the CI environments is that when we release a new version of the code, when we tag a release, we will build a Docker container of the application in the CI environment, and we will push that Docker container to Docker Hub. So here's the flow from the developer. They have working on a new feature, they create a pull request, and there's a bunch of tests that run. A peer comes in and says, yeah, the code looks good, the test passed. Let's merge it into master. And when it goes into master, the tag release, they push a tag, and then the CI runs again, and then you have the Docker build step that takes the entire application, packages it inside the Docker container, and uploads that Docker container to Docker Hub. And that is all automated, right? I mean, they haven't done any manual steps here. And once we have that, the ops team comes along and says, all right, well, you have a new container. Let's deploy it. And we use AWS a lot, but you can use Google Cloud, you can use Azure, you can use Heroku, you can use your own data center. It's the same thing. Essentially, what you want is to automate the deployment of your infrastructure, what we call stacks. So in AWS, you have something called CloudFormation. You create your stack of your servers, et cetera. And every time you deploy, you have Jenkins essentially runs through that entire infrastructure definition file and create a new stack. We use immutable servers, so between 2 releases of an application, we don't reuse the servers. We create new ones, and we point the load balancer to the new stack once we have the new release out. And the same way, the CI environment for the devs is automated, the deployment infrastructure is automated as well. In fact, nowadays, we only press a button when we want to release to production. But if you release to a staging environment, it's entirely automated. So we will have Jenkins listen from a webhook from Docker Hub. And when Docker Hub has a new version of the Docker container, it will send that ping to Jenkins and say, hey, run through the deployment stack. Jenkins will run through the deployment stack. And the developer on the left side just have to tag a release, and a few minutes later, it's deployed in the staging environment in AWS. That is entirely automated. They can run through it hundreds of times a day. Nobody needs to be involved. And so that is essentially what you will find in most DevOps pipelines. It varies. People use Kubernetes, people use OpenStack, I don't know. But it's always kind of the same workflow. And the question here is, can we integrate security testing directly into the DevOps pipeline? And if we could, that would allow us to essentially run this test before there is a production environment, right? And the answer to this, spoiler alert, is kinda. We can do a lot of these things. We cannot do everything. So I'm going to talk about the things we can do and highlight a few that we can't. And this is a 4-step process, essentially. The first one is, before you do any of these automation things, you need to know what your security baseline is. What is a set of things you want all of your developers and all your operators to do when they deploy a new application to production? You want to make sure that it is clear to everyone involved that when something goes to prod, it needs to match this standard, right? No surprises, no hand-wavy, oh, we're going to do a security audit, and then you come up with 20 new things they need to do 3 days before they release to prod, right? That's never going to work. So define a security baseline. And in that security baseline, your job as a security team, and what we spend a lot of time doing, is figuring out how we're going to test all of that stuff. Because it's difficult. You can test for the presence of a security header in your application, but as they said during the keynote, how do you test for authentication issues? Access control. All of these things are difficult, but this is where the security team really has value to add to the organization. And once you have figured out how to test, you can run this test continuously. And once you have run this test continuously, and your organization is on board and understands why and how you're doing these things, you can require this test to pass in order to go to prod. So let's break it down. The security baseline. This is an overview of a site called observatory.mozilla.org that we worked on a few years ago. And you can't, a few years ago, we've been working on for a few years. You can't really read what's on there, so I'll just explain. It's like basic stuff that we like to see on websites. So you have content security policy, because that's nice. You have to make sure your cookies use a secure flag and HTTP only, that your CORS is set correctly, that you have public key pinning, strict transport security, sub-resource integrity, extreme option, all the stuff that when you do web AppSec, you've seen over and over again. And the observatory will essentially give you a score. If you do everything right, you get an A+, and everybody's happy. It's kind of like SSL Labs does with TLS. And this is kind of the public-facing version of our security baseline, but it's great for essentially training the devs to caring about, for example, content security policy. That had tremendous value in helping the developers implement content security policy on their sites. But as security experts, we want to go deeper than that. We want to look at other things. So we have a security checklist that I'm going to share here, not in full details. It's online, and I can link to it. I'll probably post it on Twitter. And we have several levels in the security checklist. The first one, infrastructure, stuff that most ops can implement pretty quickly. We want logs. Every organization wants logs, but it's not always obvious. So at least you make it clear, we want logs for 90 days. And once you put that out there, you'll have a lot of people saying, actually, we don't have those for 90 days. And you find that a lot of infrastructures have to reorganize. We want good TLS, HSTS, HPKP, and something that we require at Mozilla is if you have an admin panel, it cannot be on the public internet, right? Because Equifax and others. And so we want those admin panels behind VPN. Number two, development. Those are strictly for the devs. Use Git commit signing, Git tag signing. So use your GPG key to essentially sign your tags, so that when we need to investigate an account being breached, we can go back to all of the tags, all of the commits, and say, yes, those have been signed, so we know they are trustworthy. Keep third-party libraries up to date. This is probably one of the most important things we're doing nowadays. And you have a lot of great tools out there. If you're doing JavaScript type backends, Node.js, NSP, the Node Security Project, and Greenkeeper are super useful. For Python, we like PyUp. There are others. Obviously, if you're in the Java world, you have tools there as well, Go as well. But most of the stuff we do is Python and Node.js. Static code analysis. You know, there are a lot of great tools too. And interestingly, developers are much better at using those than security teams, I found. So for example, ESLint is a JavaScript linter, but we also have a lot of security-related rules in there. And we have a massive rule set in the Mozilla organization because we put a lot of JavaScript in Firefox. And so when Firefox builds, it goes through all of these Mozilla-specific ESLint rule sets. So we want to require it for more than just Firefox, also for the backends. If you do Python, you can use Bandit. It's a great static code analysis tool. If you do Go, you can use a Go meta linter. And we put these things, we ask the devs essentially when they build a new application to go through that little checklist and make sure they do these things. Security headers. All right, must have a content security policy. I know this is not a very popular opinion, and a lot of organizations have come out saying CSP is never going to work, it's way too complicated and everything. But let me make this very, very clear. Content security policy is extremely powerful in essentially mitigating all sorts of cross-site scripting and injection issues. And if you can't modify your application or guarantee that your application will escape user content all the time, have a CSP, and you won't have to worry about XSS again. And I'm going to show an example at the end of this talk of CSP being very, very useful during security audits. But yeah, for us, it's a requirement. You want to go live, you must have a CSP, period. Web APIs, we found that a lot of web APIs are vulnerable to content injection issues because they tend to return HTML pages. And if you have a JSON or an XML API, there's no reason it should return HTML. It should never be accessed directly by a human, essentially. So we ask them to not do that. Secure and HTTP-only flags on cookies. And one thing that we started doing recently, we're trying to improve the scanning of our web APIs. And JSON APIs are not easy to discover. Essentially, you end up hitting the main page of your API, but you don't really have a good way to discover the sub-resources or browse the API. It's not like a website with a bunch of links that you can just spider through. So we asked developers to create an open API, also known as Swagger definition, and put it on their site so we can spider it and do scanning on it. And then we have some specific security features. Authenticate end users with Firefox accounts, and Mozillians, employees, with our single sign-on infrastructure. And that is, I was listening to the keynote, and essentially they mentioned that, we still deal a lot with authentication issues. Is interesting to me because we really don't at Mozilla, simply because we don't have any site that do password management or authentication management themselves anymore. We've moved all of those out. They either use, OWASP, and they either do it with Firefox accounts, or we are internal SSO. So we don't have to worry about this anymore. Sure, they could do it badly, but it's usually less of a problem than doing it themselves. Session management, still a concern. Access control, those are things that we essentially try to build awareness on. Like if people are building a new site, they should take care of these things. And then some best practices that have been around forever. Parameterize your SQL queries, limit the grants, don't run. You would be surprised how many web applications still use the admin account as a database. So they should use limited permission accounts. So procedure, escape user data. Limit user inputs. Again, a lot of applications allow you to upload an image, for example, and try to upload an image that's 2 terabytes large. You'll be surprised how many applications don't limit that by default. Enforce access control, key rotation, and crypto. Do not proxy requests from users. If you use AWS, you'd be surprised. You should really look at your web application that allow request proxying, because in AWS, the interesting thing is that you can essentially proxy a request to the 169 internal address, and that allows you to access the user data, the metadata of the EC2 instance. And when you do that, you can essentially download the temporary credential that instance was given by simply proxying from the outside. Pocket, that is now a Mozilla company, was vulnerable to that a couple of years ago, and we've seen it in new projects as well. You had a question, I think? Oh, sorry, yes. If you have instances in EC2, right, and you proxy user requests, an attacker can potentially ask the application to proxy a request to the internal 169 address. And by doing so, can, from the outside, retrieve the instance metadata that may contain STS tokens or credentials the application was given. And that's a problem we've seen in applications that proxy requests for the user a lot. All right, so we have a baseline. We have a checklist. It's pretty long. There's a lot of stuff in there. But now we want to test it. And that's the fun part, because we all like writing tools, right? And in fact, we'd rather spend our entire day writing tools. It's a lot more fun than doing all of the other things. And we write tools in the team. I'm going to assume most of you are familiar with OWASP Zap, because it's a pretty popular web application scanning tool. We're lucky to have Simon Bennett in the team, who is the lead on the Zap project. So obviously, he does a lot of Zap, and we've done a lot of our testing automations through Zap. But we also use other tools. I mentioned ESLint and NSP. I mentioned PyUp. So we use tools that are scanning focused, but we also use tools that would go look at the source code and do things that Zap isn't suited for. So how do we do that? Let me show you a few examples of how we do things. Let's start with Zap. So Zap is a GUI application, right? And if you want to run something in automation, you can't really run a GUI application. So what we did here is we packaged Zap inside of a Docker container. And we run a headless version of Zap to scan an application. So if you want to test it out, the Zap folks will love to have you download their Docker container, the Zap to Docker Weekly. And using that container, you can do a Docker run of the container and call the zap-baseline.py script. Give it a -t flag and point it at a website, and it will go and scan that website by default for up to a minute. You can modify that. So it's a scan that will only take 1 minute. And it's good because 1 minute is about the maximum amount of time you want to block a CI pipeline for. You don't want to block for like half an hour. It's not realistic. But a lot of web application scanners will take 15, 20 minutes, if not 6 hours to spider an application. So we time box it to 1 minute. And what it will return is a summary of the issues it's found. For example, here we have 5 failures and 4 warnings, and 1 information and 6 ignore, and 39 that pass. Now, if we look at the detail here that is returned by that scanner, it's very, very close to what we had in the checklist on purpose. So here we will have, for example, a cookie was found that doesn't have the HTTP only flag. We will have the XSS protection that is not enabled on a particular resource here, page.cgi. So that's content security policy that is missing from that page. Or we will have a missing anti-CSRF token on the homepage of Bugzilla. And these are pretty clear recommendations. It's the same stuff you will find in the Zap GUI, except you get it in text form. And it's pretty easy to parse, right? You can give that to a dev team and tell them, okay, just run that every time you release a new version, and you'll get a short report that tells you what you're doing good and what you're not doing good. We also have support for a configuration file to help enable or disable some of these checks depending on, maybe you don't want to require a CSP, so you can turn that off. If you want more information on this, there is a blog post from a few months ago from Simon on blog.mozilla.org/security, and go look for that. It's called Zap Baseline something something. Other things, I mentioned Bandit. Bandit source code analysis, you can point it at the source code of an application. Here, Kinto. Kinto is a document database written in Python. And same way, it would just look at your source code, That doesn't take too long. It takes, I think, between 30 seconds and a minute, and it will return a number of issues. And the interesting thing here, this is one of the issues categorized as high. The input method in Python 2 will read from standard input, evaluate, and run the resulting string as Python source code. That is interesting. And so in Python 2, you should use raw input. In Python 3, input is fetched. So in this particular case, because Kinto is run as a Python 3 application in the Mozilla infrastructure, we are not vulnerable to this. So we would treat this as a false positive. But it's an interesting data point here, I think, and something that the developers can easily go through, look at, and be like, yeah, I think we're fine, or no, we need to change this. And we can do this sort of tests on the applications, but also on the infrastructure. There's no reason we shouldn't test our infrastructure. In fact, we should test our infrastructure exactly the same way we test our application, because in DevOps, infrastructure is managed as code. So in the case of running stuff in AWS, you already have a lot of tools that exist that will essentially parse your AWS configuration from the AWS API and find issues. And you can do that as a security team regularly to look for example, databases that are open to the internet, or wide permission given to an account, things like that. But in CI/CD, if you want to run things during your deployment pipeline, you can also test your configuration as you go through the pipeline. And this is a little proof of concept I wrote a year ago, where essentially we have a test file on one side that will say, for a given application, we will have 3 tiers. We'll have a load balancer, we'll have an application server, and a database. And in that application, we will have firewall rules that open the load balancer to the internet. Then another firewall rule that will allow the load balancer to talk to the application, and a third one that will allow the application to talk to the database. We have that definition file written here, right? And it's pretty easy. It's really, there's no complexity here. And then we can run that file. We can run the Pineapple tool against, if you wonder why it's called Pineapple, it's because I had, for the first time, grown a little pineapple on my patio. It was like this big, and I thought it was fantastic, so that's why it's called Pineapple. Nothing to do with security. And we can run the tool against the infrastructure as we deploy it, essentially. And here what we will have is the stack is deployed. We're in staging, the stack is deployed. Pineapple will go look at the security configuration and say, I'm finding the rules that opens the load balancer to the internet. I'm finding the rule that opens the load balancer to the application, but I'm missing the database rule. Or maybe here you will have a rule that says, hey, I found a rule that opens the database to the internet. I'm not going to pass that test. And you're in your staging environment, you're in your staging pipeline, you say, I don't want to go to prod. My configuration isn't ready to go to prod because I have an anomaly in my configuration. You can go that with TLS configuration as well. TLS Observatory is our security scanner that's part of the Mozilla Observatory, specifically on TLS. And you can say, for example, I want addons.mozilla.org to always have an intermediate configuration. If you've ever looked at Mozilla's SSL recommendations, we have levels, and intermediate is the intermediate level. And if we want to integrate that into a CI pipeline, we'll say, well, addons.mozilla.org needs to always have intermediate configuration. So we will run that tool, and if it is evaluated as intermediate, we'll return a code of 0, which will say, okay, everything is good, you can go ahead. So we can run this test at the application level, source code level, and infrastructure level. Like, it doesn't really matter which part of what you're trying to test. What matters is that it is actually testable. So you need to break down your security baseline in items that you can test for. And once you have that, you can test continuously. This is our pipeline that we discussed earlier, and there are 2 areas where we want to test. So Circle CI being the kind of the developer side of it, and then AWS. And I'm going to show that example with Zap. Here's how we do it. This is a Circle CI configuration file. And if you've ever used Circle CI, this is familiar to you. This is a simple YAML file that declares the steps you're going to follow when you run through the pipeline. And here we're going to imagine it's a Go application, right? We're in the CI pipeline, we'll say, okay, run my application. So you do go run my app.go and put that in the background. And it starts the application and makes it listen on local port, for example, 8080. Great, now I have a local server running that's inside the CI job, right? And I can pull down the OWASP, the Zap container, and point it at the local application that's running. What I'm effectively doing here is that the developers are probably running a pull request. They have code that has not yet been merged to master. And I'm exercising those code with our security tests right away before it even is merged into the master branch of the repository. I can also run static analysis code in that environment. And this is very early on. This feature may not even make it ever inside of the product for various reasons, but we're already testing it for security. And we give that feedback to the dev in their pull request. What's interesting here is not so much the security testing. Like, we've been doing web application scanning for years. What's interesting here is that there are no security people involved. The developers do that on their own. We build the tooling for them, we integrate it for them, and then they can own it, run away with it, and be the gatekeepers and make sure they don't regress in security. And so once we have built that culture, once we have the devs, and this works. I mean, we see devs using these tools and running them. And we can start gating production deploys. And essentially, the way we want to do this, as I said, is that we want to integrate the production, the pre-production scans, so the staging scan, inside of the Jenkins pipeline. So if you're not a user of Jenkins, a Jenkins pipeline is the same as essentially all of the CI jobs. It's a series of steps you're working through, right? And here, for example, we will have a job that will be a build, that starts with a build. So it will build the application, build the infrastructure, right, and make everything ready. And then once the new stack is ready, we'll deploy the application on it. And at that point, you have an environment that is available, that is ready to go. And we will trigger a zap scan of that environment automatically. So we're still in the staging environment. We know we're close to production here. And then once our zap scan is done, maybe we're doing other things. In this particular example, they wanted to invalidate the cache. Okay. And if that comes back green, if we're happy with it, we can tell the devs, sure, you can go to prod. Actually, we don't even tell them. They see it directly in the feedback of the job. This is how we integrated it. So Jenkins has its own like little groovy language, and we just put that little snippet to the zap scan in every pipeline, and it integrates with every job. It's a template. So essentially, every time the ops team creates a new pipeline, they inherit that stuff. Does it work? This is a tweet I posted a couple of months ago. We were releasing a new version of a service called the send.firefox.com to send files. It's encrypted, it's cool. And this was one of the first instances where the service went out and was green all over the place. A+ on the observatory, content security policy, everything. This is another example of a security audit that we ran not too long ago with the great guys from Cure 53. And they were essentially poking at the application. And I really like that little sentence here. They found an issue they categorized as high and then said this problem is largely mitigated by the CSP in place. And the reason we have the CSP in place is because we did all of that work in the first place, because we have automated testing, because we have clear baseline requirement, because we're close to the DevOps pipeline. And we can really be ahead of the curve and work with the devs in their pipeline to implement these things. Here's a third one. Web bounty payouts over the last 2 3/4 of a year. 2015, we had 52 payouts for the bounty program. 2016, we had 43 of them. Projected for 2017, we only have 21. We cut that number by half. And we still get a whole lot of reports, but these reports are much, much lower. We don't even have that many XSS reports anymore. I remember a couple of years ago, addons.mozilla.org had like an XSS every couple of weeks. We put CSP on it. I don't know, maybe we've had 1 or 2 since. So the value here is not so much the money we save on the bug bounty program, because that's not that much money at the end of the day. The value here is that we save time from the security guys who have to triage the bounty reports, the developers who have to write the fix, and the operations team that have to deploy this thing. We save time and money for all of these people, right? And simply by making our security testing more flexible and better integrated with the developer workflow and with the ops workflow. So, in summary, if you want secure application in a DevOps world, start by defining your baseline security. right? Drive testing from the DevOps pipeline. It doesn't mean you will stop doing manual testing. It doesn't mean you will stop doing all the stuff we were doing before. But all of the items you can automatically test for, automatically test for. Don't do it manually. Get that off your plate and focus on the more complex stuff. That will allow you to not deploy substandard code anymore, not have to play catch up, and save you time to work on stuff you've never dreamed you would be able to work on. When was the last time you had time to fuzz a web application? I don't know. But by saving time on these basic issues, you can reallocate it to more complex, interesting problems. So that's the main point. I'm sure over the next couple of days, we will be hearing a lot more about how various organizations have integrated continuous testing in their DevOps environments. There are many, many ways to do this, but I think the core principle is essentially stop doing things by hand. And maybe even by the end of this conference, we'll have figured out if we want to call this SecDevOps, DevSecOps, or DevOpsSec, but I'm not have too much hope on that one. So that's my talk. If you have any questions, I'm happy to take them. Have a little game if you're interested in that kind of stuff. Manning was nice enough to give me 5 discount code, actually free ebook copies of Securing DevOps. So if you want to get one, play this little game, get an A+ on your site, post that little sentence under /Securing DevOps and ping me on Twitter, and I'd be happy to give a code to get a free ebook to the first 5 to ping me on Twitter. And if you have any questions, I think we have a few minutes, I'm happy to take them. Thank you.